Corporal Friedrich Weber's fingers wouldn't stop trembling as he gripped his pencil, attempting to document what his eyes were witnessing through the observation scope. Where Observation Post 7 had dominated the landscape just 20 minutes ago, nothing remained but a smoldering pit of destruction. That bunker wasn't some hastily constructed fieldwork. It was a fortress of reinforced concrete, engineered to survive direct impacts from shells measuring 210 millimeters in diameter. The engineers from the Todt organization had inspected and approved every inch of its construction back in 1943, guaranteeing its strength. 32 soldiers from the 915th Grenadier Regiment of the 7th Army had manned that position continuously since September 1944. On this frozen November morning, the 14th day of the month, those men had simply ceased to exist. Weber pressed his face harder against the periscope lens, desperately scanning the distant forest edge beyond the Mirth River Valley. His eyes searched for something, anything, but there was nothing to see. No telltale muzzle flashes piercing the morning gloom. No rising columns of smoke betraying enemy positions. Not a single clue about where that devastating shell had originated. The trembling in his hands wasn't from the bitter cold seeping into the bunker. It was something far more disturbing. A dawning comprehension that shattered everything the Artillery Academy in Jüterbog had taught him. The Americans had launched their attack from a distance that shouldn't have been possible. They had fired from ranges that German military doctrine classified as beyond the maximum effective range for heavy artillery, and they had achieved a perfect hit on their very first shot. Before we continue with this incredible story of technological warfare, make sure you're subscribed to the channel. Drop a comment below and tell us which corner of the world you're watching from today. We love hearing from our global community. The weapon that had just demonstrated such terrifying capability carried a deceptively simple nickname among American troops: the Long Tom. Its official designation was the M1 155mm gun. What Weber and countless German defenders positioned along the fortified Siegfried Line were experiencing throughout the autumn months of 1944 represented something the Wehrmacht High Command had deemed theoretically impossible. The Americans had perfected a system for systematically demolishing hardened fortifications from such extreme distances that German counter-battery fire became completely ineffective. The Long Tom could deliver accurate fire at targets 14 miles distant, a precision that left German artillery crews utterly baffled. More concerning still, these devastating weapons were arriving at the front in quantities that reflected America's industrial might, operating at a scale that Germany's war economy could no longer hope to match. But how did this terror weapon come into existence? The origin story of the Long Tom doesn't begin on any battlefield. It starts in the surprisingly mundane offices of the United States Army Ordnance Department during 1938. While European military forces had dedicated the years between the world wars to developing progressively more powerful artillery systems, American military thinking remained largely trapped in the past, anchored to lessons learned during the First World War. Back then, the French 75mm field gun had been considered the absolute peak of what artillery science could achieve. However, by 1938, disturbing intelligence was flowing back to Washington. Army observers stationed in Spain, witnessing the brutal Spanish Civil War firsthand, were sending back reports that couldn't be ignored. They documented that modern fortifications, built with contemporary engineering techniques, simply couldn't be destroyed by any artillery pieces currently in the American arsenal. The War Department found itself facing an urgent requirement. They needed a weapon capable of hurling a 95-pound shell across at least 25,000 yards of distance while maintaining sufficient accuracy to strike specific fortified structures. The specifications seemed to contain contradictions. This gun would need mobility to keep pace with rapidly advancing mechanized units, yet simultaneously possess the raw, destructive power typically associated with massive railway artillery pieces. It required pinpoint accuracy at distances that pushed engineering limits, while remaining simple enough for rapid mass production in American factories. The weapon's weight needed to stay low enough for truck-mounted transport systems, yet it would have to absorb and manage truly enormous recoil forces with each shot. The engineering team at WWII Arsenal in New York State tackled this challenge with a distinctly American approach to problem-solving. Instead of trying to compromise on the gun's performance, they decided to build the most powerful mobile artillery piece that physics would allow, then figure out how to transport it afterward. The result was a triumph of practical engineering that balanced competing demands brilliantly. The M1 154mm gun featured an impressively long barrel measuring 23 feet, with the barrel assembly alone weighing a substantial 6,400 pounds. When fully assembled and positioned for firing, the complete weapon system tipped the scales at 30,700 pounds. This massive weight necessitated an innovative two-piece transportation solution. The barrel and breech mechanism traveled on one specially designed carriage, while the trail assembly and firing platform moved separately on another. A highly trained crew, working with practiced efficiency, could complete the deployment process in roughly 45 minutes, though battlefield conditions frequently extended this to over an hour. Once in position, the gun could maintain a sustained firing rate of 1 round every 2 minutes, or accelerate to 1 round per minute during brief periods of intensive fire. Using standard ammunition loads, the maximum effective range reached 25,615 yards. That's just over 14.5 miles. Manufacturing began slowly during 1941 at WWII Arsenal. The initial guns equipped newly formed field artillery battalions as the United States Army underwent massive expansion from its skeletal peacetime force structure. By 1942, production rates had accelerated dramatically to satisfy the demands of fighting a global war across 2 vast oceans. WWII Arsenal alone manufactured 462 Long Tom units between 1941 and 1945. Additional contracts with Baldwin Locomotive Works and various other defense contractors pushed total production to approximately 1,060 units. Each individual gun carried a price tag of roughly $38,000, comparable to the cost of a medium tank, but their strategic impact would prove impossible to measure in mere dollars. The Long Tom made its combat debut during Operation Torch, the Allied invasion of North Africa, in November 1942. The 36th Field Artillery Brigade brought the first of these weapons into combat during the Tunisia campaign in early 1943. German forces defending the strategic Kasserine Pass encountered American heavy artillery for the first time, and initially they weren't particularly impressed. The Green American gun crews struggled with fire control procedures, and German counter-battery fire proved effective at suppressing American positions. General Hans-Jürgen von Arnim, commanding the 5th Panzer Army, noted in his March 1943 situation report that while American artillery was present in large numbers, it suffered from poor coordination, with heavy guns frequently caught out of position and exposed to German artillery fire. This assessment, however confident it might have seemed at the time, would prove catastrophically mistaken within just 18 months. The American military was absorbing lessons from combat at a remarkable pace. The Tunisia campaign had brutally exposed deficiencies in fire direction procedures, communications systems, and tactical deployment. The artillery schools at Fort Sill, Oklahoma, responded by working overtime, refining the fire direction center concept that would fundamentally revolutionize how artillery warfare was conducted. By the time American forces stormed ashore in Sicily during July 1943, Long Tom battalions had become fully integrated into a sophisticated fire control network that multiplied their battlefield effectiveness exponentially. The Italian campaign provided a devastating demonstration of what properly coordinated American artillery could accomplish. Long Tom batteries attached to the Fifth Army methodically dismantled German defensive positions along successive fortified lines, the Winter Line, the Barbara Line, and the formidable Gustav Line. At Monte Cassino, where elite German paratroopers had transformed an ancient monastery into what they believed was an impregnable fortress, Long Tom batteries positioned near Mignano could deliver fire on every German position across the mountain. Forward observers embedded with the 2nd New Zealand Division called in precision strikes that destroyed German bunkers systematically, one fortification at a time. The Germans responded with furious counter-battery fire, attempting to silence the American guns, but the Long Toms sat comfortably miles behind the front lines, safely beyond the reach of German artillery systems. Oberstleutnant Julius Schlegel, serving as artillery commander for the 1st Parachute Division at Cassino, was captured in May 1944. During his interrogation, he described the psychological impact with disturbing clarity. "We could hear them firing from incredibly far away, like distant thunder rolling across the mountains. Then the shells would arrive. Massive, heavy shells, and our concrete fortifications would simply crack apart. We made desperate attempts to locate their battery positions, but they were firing from distances our own 150 mm guns simply couldn't reach. There was nothing we could do except endure the bombardment." The technical sophistication of the American fire control system completely bewildered German artillery officers who had been trained in traditional methods emphasizing direct observation and massed batteries firing in coordinated volleys. The American approach operated on an entirely different philosophical foundation. Forward observers, often positioned directly with frontline infantry units or operating from lightweight spotter aircraft, would identify targets and radio-precise coordinates back to a centralized fire direction center. These FDCs were staffed by soldiers extensively trained in trigonometry and ballistics calculations. They would compute firing solutions using graphical firing tables, current meteorological data, and detailed information about each individual gun's unique characteristics. This system allowed multiple artillery batteries to coordinate their fire, placing shells on a single target simultaneously even when firing from different positions separated by miles. This time-on-target technique could blanket a German position with dozens of shells arriving within seconds of each other, providing defenders with absolutely no warning and zero time to seek cover. The Long Tom's remarkable accuracy at extreme ranges resulted from multiple engineering factors working in harmony. The extended barrel length provided exceptional velocity and stability to the projectile. The sophisticated recoil system absorbed tremendous forces while maintaining the gun's position. But perhaps most critically, American ammunition quality remained consistently high throughout the war, while German shell manufacturing had begun to suffer from resource shortages and the increasing use of forced labor. American ammunition factories maintained rigorous quality control standards. Each shell underwent precise machining to ensure consistent weight. Distribution. Powder charges were measured with exacting precision. Fuses were manufactured to reliable specifications. This attention to detail meant that American gunners could trust their ammunition to perform identically, shot after shot, enabling the mathematical precision that characterized American artillery operations. The Germans, by contrast, faced increasingly severe quality control problems as the war progressed. Sabotage by forced laborers, shortages of critical materials, and the disruption caused by Allied bombing campaigns all contributed to declining ammunition reliability. German gunners discovered that shells from different production batches might fly differently, making accurate long-range fire nearly impossible. Stay with us because what comes next reveals how these artillery pieces broke the back of Germany's most formidable defensive line, and the German soldiers' own words about facing this unstoppable weapon. The Siegfried Line, which the Germans called the West Wall, represented the culmination of pre-war German military engineering. Stretching over 390 miles from the Netherlands to Switzerland, this defensive complex included over 18,000 bunkers, tunnels, and obstacles. German military planners had invested enormous resources into creating what they believed was an impregnable barrier against any Western attack. The fortifications featured reinforced concrete bunkers with walls 6 feet thick, interconnected by underground tunnels, protected by extensive anti-tank obstacles and minefields. German propaganda had convinced both military personnel and civilians that the West Wall was effectively invincible. Newsreels showed German soldiers confidently manning these positions, with narrators assuring audiences that not 1 meter of German soil will be surrendered. The soldiers stationed in these fortifications had been trained to believe that the combination of concrete, steel, and German discipline made their positions unassailable. The American assault on the Siegfried Line, beginning in September 1944, shattered these beliefs with terrifying efficiency. The Long Tom battalions attached to the 1st and 9th Armies demonstrated what sustained, accurate heavy artillery fire could accomplish against even the most formidable fortifications. The tactics were methodical and brutally effective. Forward observers would identify specific bunkers for destruction. Fire direction centers would calculate precise firing solutions, accounting for range, weather conditions, and target characteristics. Long Tom batteries would then deliver sustained fire on individual targets, sometimes firing dozens of shells at a single bunker over hours or even days. The massive 95-pound shells, impacting with devastating kinetic energy, would methodically crack open even the heaviest concrete fortifications. German defenders discovered that their supposedly impregnable bunkers offered only the illusion of safety. A direct hit from a long Tom shell could penetrate concrete walls that were designed to resist smaller caliber weapons. Near misses would crack foundations and weaken structures. Sustained bombardment would systematically destroy fortifications that German engineers had claimed would last for decades. The psychological impact on German defenders cannot be overstated. Soldiers who had been assured of their safety found themselves trapped in concrete tombs that were being systematically demolished. The constant threat of sudden obliteration from an enemy they couldn't see or reach created severe psychological stress. Medical records from captured German units show increasing rates of what the Wehrmacht called combat fatigue, what we would recognize today as combat stress reaction, or PTSD. Gefreiter Klaus Zimmermann, captured near Aachen in October 1944, described the experience during interrogation. The American artillery was like nothing we had ever encountered. They would select a single bunker and destroy it methodically, shell after shell, hour after hour. You would watch through periscopes as they demolished positions all around you, knowing that eventually they would target your bunker. The waiting was sometimes worse than the actual bombardment. You knew they would find you. You knew your bunker, which we had believed was safe, would offer no real protection. Many men simply broke mentally before the shells ever arrived. The effectiveness of American artillery went far beyond simple destructive capacity. The American military had developed sophisticated psychological warfare techniques built around their artillery superiority. Intelligence officers understood that the systematic destruction of fortifications had profound psychological effects on enemy morale. Rather than simply blanketing areas with indiscriminate fire, American batteries would often target specific, prominent fortifications, destroying them with precision that demonstrated American technical superiority and the futility of resistance. This approach proved far more effective at breaking German morale than massive but less accurate bombardments. The message to German defenders was clear and terrifying. American artillery could identify your specific position, target it individually, and destroy it with mathematical certainty. No fortification, no matter how strong, guaranteed survival. The material resources supporting American artillery operations were equally impressive and equally demoralizing to German defenders. While German artillery batteries struggled with chronic ammunition shortages, American Long Tom batteries received ammunition in quantities that seemed unlimited to German observers. Captured German soldiers frequently expressed shock at American ammunition expenditure, often claiming that Americans fired in single engagements more shells than their entire unit would receive in a month. This impression wasn't entirely inaccurate. American ammunition production and logistics had reached levels that represented a fundamental difference in kind, not merely degree. American factories were producing artillery shells by the millions, shipping them across the Atlantic in vast convoys, and delivering them to frontline units with remarkable reliability. The logistics system supporting American artillery represented perhaps the most impressive organizational achievement of the war, one that German forces, with their overstretched supply lines and dwindling industrial capacity, simply couldn't match. But here's something that will surprise you. The individual stories of the Americans who operated these devastating weapons reveal a more complex picture of artillery warfare than simple technical superiority might suggest. The men who crewed the Long Tom batteries came from remarkably diverse backgrounds. Staff Sergeant Robert Williams, Section Chief with the 95th Field Artillery Battalion, had been a high school mathematics teacher in rural Ohio before the war. His training in trigonometry and geometry, skills he'd never imagined using in military service, proved invaluable in the precise calculations required for accurate long-range fire. Private First Class James Morrison, from a farming family in Iowa, brought mechanical aptitude developed repairing farm equipment to maintaining the complex gun mechanisms. Corporal David Chen, a second-generation Chinese-American from San Francisco, served as a forward observer, a position requiring exceptional courage as it placed him in the most dangerous positions on the battlefield. These ordinary Americans, drawn from every region and background, operated weapons that terrified professional German soldiers who represented a military tradition stretching back centuries. The democratic nature of the American military system, which promoted based on ability rather than social class or family connections, created artillery units that were remarkably efficient and adaptable. The training American artillerymen received was extensive and sophisticated. Fort Sill, Oklahoma, the home of Army artillery training, had developed comprehensive programs that turned civilians into skilled artillery professionals in months. The training emphasized not just mechanical operation of the weapons, but mathematical precision in fire direction, effective communication procedures, and integration with infantry and armor units. German artillery training, while thorough, remained more traditional, emphasizing time-honored procedures that hadn't fundamentally changed since the First World War. American training was constantly updated based on combat reports, incorporating lessons learned from North Africa, Italy, and the Pacific. This willingness to adapt and innovate gave American artillery a crucial edge in effectiveness. The experience of serving in a Long Tom battery was physically demanding and psychologically complex. The crews worked with dangerous weapons that required constant maintenance. The physical labor of moving ammunition, preparing firing positions, and operating the heavy gun mechanisms was exhausting. Combat conditions added additional stress. Even though Long Tom positions were typically miles behind the front lines, they remained vulnerable to German counter-battery fire and aerial attack. Yet there was also a curious psychological distance from the violence these weapons inflicted. Unlike infantrymen who saw their enemies face to face, artillery crews killed at distances that made their targets abstractions. They fired at coordinates on maps, not at human beings they could see. The shells flew for nearly a minute before impact, disappearing into the distance. The crews rarely witnessed the destruction they caused. This distance created a moral ambiguity that some veterans struggled with for decades after the war. Staff Sergeant Williams, the former teacher, described this in a 1987 interview. "We were extraordinarily good at our jobs. We could place a shell through a specific window from 12 miles away. But we never witnessed what happened when it impacted. We never saw the men we killed. Sometimes I wonder whether that made it easier to do or harder to live with afterward." The industrial production system that enabled American artillery dominance represented democratic capitalism operating at peak wartime efficiency. Watervliet Arsenal, Baldwin Locomotive Works, and dozens of other American facilities produced over 1,000 Long Tom guns while simultaneously manufacturing thousands of other weapons systems. Ammunition factories turned out millions of shells monthly. The logistics system delivered these munitions to fighting units with remarkable consistency. This production came from free workers earning fair wages, operating without coercion in factories that, while demanding wartime production, respected basic labor rights. This contrasted sharply with German war production, which became increasingly dependent on slave labor and operated under constant disruption from Allied bombing campaigns. The Long Tom's success validated a fundamental American military philosophy. Overwhelming material superiority, precisely applied, could substitute for operational brilliance. German generals, products of a military tradition that emphasized elegant maneuver and tactical sophistication, found themselves struggling against an enemy that solved problems by applying tons of high explosive with mathematical precision. Field Marshal von Rundstedt, captured at war's end, offered this assessment during his interrogation. "You Americans do not fight like soldiers in the traditional sense. You fight like engineers. You identify the problem, calculate the solution, apply overwhelming force at the critical point, and then methodically move to the next objective. There is no glory in your methods, but the effectiveness is absolutely devastating." This comparison between German and American artillery programs reveals fundamental differences in how the two nations approached modern warfare. Germany produced technically sophisticated weapons in limited numbers: the massive railway guns, the advanced rocket systems, the precision optical equipment. These weapons represented engineering excellence, but they proved strategically irrelevant because Germany couldn't produce them in sufficient quantities to affect the war's outcome. America produced good weapons in overwhelming numbers. The Long Tom wasn't the world's most powerful artillery piece, nor the most accurate, nor the longest ranged. But America built over 1,000 of them, provided effectively unlimited ammunition, and integrated them into a fire control system that multiplied their battlefield effectiveness exponentially. And the story doesn't end with World War II. The legacy of the Long Tom extended decades beyond VE Day. The M1 gun remained in active U.S. Army service throughout the Korean War, where it reprised its role as a bunker buster and fortification destroyer. During the siege of Outpost Harry in June 1953, Long Tom batteries provided critical fire support to American and South Korean defenders, delivering devastating fire on Chinese assault positions from protected positions miles to the rear. The gun's ability to deliver accurate heavy fire at extreme ranges proved just as valuable on Korean ridgelines as it had in the forests of Germany. The weapon saw limited use during the Vietnam conflict, though its lack of mobility in dense jungle terrain limited its effectiveness in that very different type of warfare. The last Long Tom guns were finally retired from National Guard service in the early 1970s, replaced by more modern self-propelled systems that offered similar firepower with greater mobility. Several M1 guns survive today as historical monuments. Fort Sill, Oklahoma, home of the U.S. Army Field Artillery School, displays serial number 47, the very gun that fired the first Long Tom round in combat during the Tunisia campaign. The Aberdeen Proving Ground in Maryland preserves number 112, which was used for extensive ballistics testing throughout the war years. These silent weapons stand as physical testament to American industrial capacity and to the soldiers who served them with skill and dedication. The German soldiers who faced the Long Tom carried their memories of that experience until their deaths. During the 1990s, as the last World War II veterans entered their final years, extensive oral history projects captured their recollections. A consistent theme emerged from these interviews: the terror of facing an enemy who could kill from beyond visual range, the helplessness of watching supposedly impregnable fortifications disintegrate, and the collapse of faith in defensive doctrines that had been taught as absolute truth. Former Grenadier Paul Schmidt, who survived the defense of Aachen, spoke for many of his comrades. "We had been told repeatedly that the West Wall was impregnable. We believed in German engineering, in our concrete and steel fortifications. The American artillery taught us that we had believed a lie. No wall, no matter how thick, could protect us from shells falling with mathematical precision. We learned the hard lesson that industrial power, properly applied, defeats any fortification." The shock that German defenders experienced wasn't merely tactical, it was philosophical. The Wehrmacht had been trained in a military tradition stretching back to Frederick the Great, a tradition emphasizing elegant maneuver, concentration of force at the decisive point, and the supposed moral superiority of the German soldier. American artillery, grinding away at German positions with mechanical efficiency from distances that precluded any effective response, negated this entire tradition. The Americans weren't seeking glorious battlefield victories in the traditional sense. They sought systematic destruction of enemy forces using overwhelming material advantage, and it worked with devastating effectiveness. The Long Tom's 14-mile reach meant that German defenders could never feel truly safe. Forward positions faced direct fire. Reserve positions were targeted with precision. Supply routes were interrupted by interdiction fire. Command posts were systematically destroyed. The entire depth of the German defensive zone lay under constant American artillery threat. This differed fundamentally from earlier forms of warfare, where armies could establish rear areas beyond artillery range, where soldiers could rest and regroup in relative safety. The Long Tom made such sanctuary impossible. Every German soldier positioned within 14 miles of the front line lived under constant threat of annihilation from a weapon he could neither see nor effectively engage. The psychological warfare aspect was entirely deliberate. American intelligence officers understood that destroying a single bunker with precision fire demoralized defenders far more effectively than massive but indiscriminate barrages that left fortifications mostly intact. The message was crystal clear. American artillery could find you, target you specifically, and destroy you with mathematical certainty. No fortification guaranteed survival. The only real safety lay in surrender or retreat, and retreat merely postponed the inevitable encounter with American firepower. The material disparity between American and German forces by late 1944 had become so vast that German soldiers often expressed amazement rather than anger. Nazi propaganda had convinced them that Germany possessed superior weapons and technology. The reality of facing unlimited American artillery, supported by complete air superiority and lavish logistics, shattered these carefully constructed illusions. Many German prisoners of war expressed genuine relief at their capture, viewing it as escape from a contest they clearly couldn't win. The Long Tom story ultimately represents industrial democracy defeating military autocracy. The United States produced over 1,000 of these guns, millions upon millions of shells, trained thousands of skilled artillerists, and delivered everything to the battlefield with reliable efficiency. Germany, operating with a smaller industrial base that was being progressively crippled by strategic bombing and cut off from essential resources by naval blockade, simply couldn't compete on these terms. The technical sophistication of German weapons, while impressive, couldn't compensate for American quantitative superiority. 1,000 Long Toms, adequately supplied with ammunition and integrated into an effective fire control system, accomplished what Germany's engineering brilliance couldn't prevent: the systematic destruction of German defensive capacity. The final irony of the Long Tom's success is that it achieved its devastating effects through fundamentally simple means. A large gun firing a heavy shell with accurate fire control and unlimited ammunition. No revolutionary technology was involved in the basic concept. The gun's design employed well-established principles of artillery engineering. The shells were conventional high-explosive rounds. The fire control system relied on basic trigonometry and careful measurement. What made the entire system devastatingly effective wasn't some secret technological breakthrough. It was the American ability to produce everything needed in vast quantities and deliver it where and when it was needed. The Germans possessed the technical knowledge to design and build similar weapons. What they lacked was the industrial capacity and access to resources necessary to produce them in meaningful numbers, while simultaneously fighting a global war on multiple fronts. Thanks for staying with us through this deep dive into military history. If you found this story compelling, check out our other detailed historical videos appearing on your screen right now. And don't forget to subscribe so you never miss our next story.